How's everybody doing out there? Well, welcome to day 11 of Corona Online School. So, we just finished up chapter 6 and we're moving into chapter 7, our final unit for the semester. So, we're going to be talking about decimals and rational and irrational numbers. So, if we look at the classwork, we're starting off today with kind of a real number system graphic organizer. And so what we want to do is kind of fill in the chart of where all of our different numbers would live. So if we look at our big smallest square in the middle, like that's actually going to be where our natural numbers live. And then what's a little bit bigger than the natural numbers is of course the whole numbers. And what's a little bit bigger than the whole numbers is going to be the integers. And then what's a little bit bigger than the integers is going to be the rational numbers. And then if you notice, we've got this big blank area over on the right hand side. So this is actually consists of what's called all the irrational numbers. So these are numbers that are kind of the weird numbers. They're numbers that can't be written as a fraction. They're decimals, kind of go on and on and on forever without repeating or anything like that. So if we take all of these things in the box together, then what we end up getting is our real number system. So real numbers consist of everything inside of these two squares. So again, just to kind of write down a few irrational numbers, so like pi would be a good irrational number, e, anything with a square root, square root of 2, square root of 3. There's all kinds of weird irrational numbers that are out there, but these just gives you a few to think about. So down at the very bottom, we're just going to summarize our real number system. So remember, our natural numbers are just the counting numbers. So it starts with 1 and then goes on from there. Our whole numbers are our counting numbers, but including 0. Our integers is every whole number, positive and negative. And our rational numbers are all of our anything that can be written as a fraction. So it's really things of the form a over b, where a and b are integers. And our irrational numbers are going to be the numbers that can't be written as fractions. And another way to think about it from a decimal perspective is their decimals are non-repeating and never ending. Sometimes you'll hear it called non-terminating. All right. So for fun, I'll let you guys try the true or false ones. We may use that as our exit ticket just so that way we can see how we did. And then what we want to do for number 2 is we want to complete these tables determining whether numbers are fall into different categories. So remember, just like our graph at the beginning, if you're a natural number, you're also a whole number, you're also an integer, you're also a rational number. So that way, so you can be in more than one category when you're doing these guys. So for example, if I look at 8, 8's definitely a natural number because it's a counting number, which means it's a whole number, it's an integer, it's a rational number. Now it can't be irrational because remember it's on the left-hand side of our chart, so only these weird numbers are going to be irrational. So in this case, this would be a no, and then pretty much all the numbers we're going to deal with are going to be real numbers almost, except for the last one. The last one's kind of a weird one because it's undefined. And there's also imaginary numbers, which you may have heard of, but we're not going to talk about those things. Those wouldn't be real numbers either. So the majority of the things on our thing are going to be real numbers. So I'll let you try the rest of these guys to see how we do. And so if you look at the next chart, so we did this a little bit ago with fractions. So now if you notice we've added a decimal column here. And so we've turned these fractions into decimals. So 1/10 is the same as 0.1 or 1/10. 1 over 100 would be 0.01. 1 over 1,000 would be 0.001. So with that in mind, what we want to do is write expanded notation using these exponentials. So if we looked at 234.62, when we wanted to write this in exponential form, and again, we might want to decompose it first. So 200 plus 30 plus 4 plus 0.6 plus 0.02. And so in this case, this would be 2 times 10 to the second plus 3 times 10 to the first plus 4 times 10 to the 0 plus 6 times, so it'd be 1 over 10 or 10 to the negative 1 plus 2 times, 2 times, so 1 over 100 or 10 to the negative 2 in that case. So I'll leave B for you guys to do, and I'll actually leave 4 and 5 for you guys to do as well. So 4, the main thing you want to notice here is we're multiplying by hundreds, dividing by hundreds, multiplying by tens. So really think about it as moving the decimal place. Don't actually go through the multiplication. So if we're multiplying by 100, that means we're going to move the decimal place 2 places to the right. If we're dividing by 100, then that means we're going to move the decimal point 2 places to the left. So don't go through the actual multiplications, just kind of move the decimal around. So for 5, writing these fractions as decimals, all we want to do is just long divide them and see what we get. So I'll let you guys do those. So for 6, we're trying to write each of these terminating decimals as a fraction. So what we want to do is think about it in terms of their place. So in this case, 0.32 is in the hundredths place. So we could write this as a big 6 with a 32 over 100. And then now what we just need to do is simplify the 32 over 100. So I'll leave that for you guys to work on. And B would be the same way. So what I want to get to is this weird number 7. So number 7 is saying if we've got a non-terminating decimal, how can we write this as a fraction? So if we look, what we've got is 0.3 repeating. So it looks like 0.33333 forever and ever and ever. So the way we want to do this is actually want to start off by letting x equal this repeating decimal. And so now we want to do the same trick we were working on problem 4. So in this case, what I want to do is actually multiply this equation both sides by 10. So if I multiply the x by 10, I'm just going to get 10x. But if I multiply 0.33333 times 10, that's just going to move the decimal 1 place to the right. So I'm going to end up with 3.333 repeating over and over and over. So now what we want to do is actually put this original equation underneath, and we want to subtract these two equations from each other. So on the left-hand side, 10 minus 1x is just going to give me 9x. But the cool thing about the right-hand side is, notice when I do 3.333 repeating minus 3.333, all this repeating stuff just cancels out. And so all that survives is just plain old 3 in this case. So now if I just divide both sides by 9, I see that x equals 1/3, which you may have recognized from the decimal anyway. But again, that's kind of a neat trick that you can do. So the last page is just a matter of ordering these decimals from least to greatest. So sometimes they put fractions in there, so I would recommend turning everything into decimals just to make it easier to compare. So again, I'll leave these guys for you to practice. If you have any questions, I'll be around the computer all day tomorrow, and so good luck.